Hello, my name is Huseth, Research and Extension Entomologist at North Carolina State University with responsibility for sweet potato insect pest management. For several years, my program has been focused in on trying to understand the key insect pests for sweet potato production systems. The majority of our research effort has been focused in on trying to understand better management practices for wireworms, which are typically called click beetles as adults. These insects dwell in the soil as larvae and feed on enlarging sweet potato roots throughout the production season. This damage, which you'll see in photos here, really reduces the quality of roots by cosmetic damage and also maybe even quality of these roots through secondary pathogen invasion in the storage process. To try to confront this problem, we've taken a multifaceted research approach to try to understand not only the activity of this insect in the production system, but also the better management of the system using insecticides. Currently, we're confronted with a significant issue with trade barriers through the European Union for the regulated use of chlorpyrifos, which is an active ingredient called lorsban. This insecticide has been the key insecticide used for sweet potato pest management for several years. Through regulatory changes, the EU will no longer be accepting sweet potato roots that are treated with lorsban. As a result, growers will need to transition towards alternative management strategies using insecticides that are not necessarily lorsban or chlorpyrifos based. To do this, we really need to have a better understanding of active ingredients that are all currently registered for sweet potato use. To understand this relationship between efficacy for wireworms and safety for roots, we've initiated a series of studies funded by the Sweet Potato Commission to try to examine not only experimental insecticides, but also registered materials for lorsban alternatives in our production system. So here we are at the Lower Coastal Plain Research Station near Kinston, North Carolina, looking at our 2020 research study examining the efficacy of lorsban alternative insecticides for wireworm management. In this study, we're looking at neonicotinoid insecticides, diamide insecticides, and a range of pyrethroids to try to understand which of these materials can either match or come close to the efficacy that we would typically expect for chlorpyrifos. Using this study, both here in Kinston and at the Horticultural Crops Research Station at Clinton, we're better able to understand and address differences in wireworm complexes that are commonly part of the production system in different parts of our sweet potato production region. This study will try to understand really how these different materials balance against lorsban and can provide crucial recommendations based on your geographies. In addition to this study, we're looking at the activity of these insect pests throughout the production system using a range of wireworm monitoring strategies using pheromone-based monitoring and then also traditional trapping methods to understand when and where these insects are most active in our production system. The goal of this research is really to identify risk factors in the landscape that contribute to increased risk for wireworm damage. So through a range of on-farm studies looking at activity of wireworm adults, we hope to better understand periods of increased risk based on crop composition that surrounds sweet potato fields in North Carolina. Using a range of these different studies, we feel like we're both addressing the need to understand the basic ecology of this insect pest and also their applied management using traditional insecticide strategies. These studies are part of a multifaceted program in which we feel in the next several years we'll be able to provide more accurate recommendations to growers to be able to better manage this insect pest and reduce insecticide input needs in the absence of chlorpyrifos in our production system. In the future, with new active ingredients, we hope to have a better understanding of how we can more accurately reduce or target insecticide management strategies in our production system to try to mitigate any sort of damage that we would expect to have in different geographies.